So what I'd like to show you now is what we've been working on for the past year. Since the last ScaledML, we've been building rapidly. And this is joint work with everybody at Matroid. I can't take credit for even a tiny piece of it. It's really teamwork that is going to be shown here. We've built infrastructure to deal with millions of detectors and streams for computer vision. And computer vision has been largely overtaken by machine learning, which is why we're obviously very much all in on scaling machine learning. So in order to make sense of millions of streams of video and to make sense of many detectors, we have today several new pieces of the puzzle being put together. So what you see here is a calendar of events, which we'll actually get to in a live demo, of Bloomberg, the TV channel, being monitored for a bunch of different things. And the calendar of events this is a calendar of events that have happened on Bloomberg. And Bloomberg is one of millions of streams that is able to go into Matroid. And these are a few detectors. So this is Matroid running on, right now I just talked to the Nginx pod. The Nginx pod routed me to one of the Node.js pods. And I'm now talking to one of the Node.js pods. I can do one of two things. I can either create a new detector, or I can use detectors off the shelf here. I'm going to go in and look at what detectors are already available, and then I'll make some for you later. So the first detector that, there's a lot of detectors that look for different things in media and then populate that calendar that I showed you. I'm going to look at the everyday objects detector because it is one of my favorite detectors. It detects 20 things. It's no big deal that this thing detects 20 things because we'll be able to make detectors as we wish. So this one can do person, boat, car, etc. And so let's run that right now using the webcam. So if I run this if I run this with me right now, there's a person there and there's a bottle there, right? And I can sort of start inching myself out of the scene, and hopefully it still figures out that there's a person there. Eventually it will say that there's no person there. Okay. Hopefully soon. Okay, right? So now there's nothing in there. So it has figured out. Sometimes it says I'm a sofa if I'm looking like this because I just have my arm there. But we can deal with occlusion to an extent, and it's really no big deal that this thing can detect like bottles and people. I'm going to do a lot more than that. So what happened there is actually this picture was sent to one of the GPU pods classified there. It came back. And this is just a neat trick, right? But it's actually going to be very important when you start creating your own detectors to inspect how they work rapidly. We can run this live. Let's run it live on Bloomberg. So if I run this, we're going to go out through Kafka. We're going to start consuming Bloomberg US, and then take one of these detectors, start running it on every single frame of Bloomberg US, and then say we look for people. But sadly, this is, okay. Live demos have this sort of thing where if there's nothing interesting happening, then you're not going to get any interesting things. So I'm going to stop that. Like there's no people or anything I could detect out of those 20. So I'm going to change this to the C-SPAN stream. There's usually people on C-SPAN. Right? There's lots of politicians there talking about things, so hopefully the politicians there will entertain us. Yes, okay? So what is this? March for Our Lives rally by somebody, right? So this is now, this person has been detected as a person with 98% confidence, and then we can run through these. This is like a crowd of people, and then we're back to that person, right? So this is actually live. Like if you turn on C-SPAN, this is what you see. You cannot watch TV on Matroid. Don't try. There's like many ways to stop you from actually getting access to the streams that are copyrighted. If it's a stream that is your own stream, you can watch it. If it's a copyrighted stream, no. So, okay, fine. This is, yet again, it's neat. What's the big deal here? Nothing. It's really just inspecting the detector that is useful here. When I'm ready to use a detector, I can hit monitor, and then go in and select a focus area. I could say I want to monitor this stream here, and I can draw an arbitrary size polygon to do it. I can monitor a stream I could set an area that I want to monitor, and I say that, well, hey, look, I want to get notifications for people whenever something happens with 83% confidence. Give me a notification, start now, and finish never. Okay, and then I hit submit, and I end up with a screen that looks like the one that I showed you earlier. So now we're starting to see some value. There's going to be the calendar of events filled with detections that have happened on Bloomberg for these four detectors, four detectors. So this detector is looking for cars on Bloomberg. This one is looking for general people and their gender, male, female. And this one is looking for US presidents. So we have the past 4 presidents here, and they should show up on Bloomberg. So what you're seeing here is a population of exactly that. So let's say I just want to see the detections related to cars, which was the everyday objects detector, and I hit that. So this morning, it looks like at 6 a.m., there was a Tesla car on Bloomberg. Someone was talking about it. It's interesting because it's like a half-baked car. It's sort of half-built. And then there's another car and so on, right? Senate relaxes post-crisis bank rules. I haven't actually seen these. They happened this morning while we were asleep. And then we look at some of these other ones, gender detector. We should be able to see that. There's a man, right? And let's see. Hopefully we can find some women. Nope, they're all not women. Oh, come on. Yeah, OK, so here. Sorry, no, I clicked the wrong thing. There we go. OK, good. That's yeah. All right. So Theranos here is a fraud by SEC. And then there's the US presidents, right? Sadly, the past few presidents don't show up too often, and then there's the one that shows up very often these days, right? So we have now some value provided because, well, if I wanted to get these, I would have had to have an intern or something watch 24/7. Now I don't. What if I wanted to condense this data? I can look at this, like the gender distribution of people on people on Bloomberg. Here we have every gender. The gender distribution is something like 3 to 1, 2 to 1. Sorry, male to female on Bloomberg. It's kind of a business channel. It's how it is. We can look at. Hopefully it changes. Yeah, so it's not something that. Yeah, maybe we can change this. So we have all kinds of ways to look at this data. We can chop it up and look at it in different ways, visualize it. We can export this and put it in a visualization tool. We're not a visualization company for bars and charts and stuff. So you're welcome to export this data and put it anywhere you want. Okay. So far, we've just sort of used detectors, right? We haven't done anything that needs a custom detector. And I'd like to now change that and move on to creating a detector. And then that'll set me up to show you all of the newer things that we can do with regard to combining them. So let's create a detector now very quickly for say, me. And we'll do it for a celebrity that either you can choose or I can choose. So now when we hit, I want to create a detector for Reza, it says, OK, you're going to create a detector for Reza. What kind of detector do you want? I want a face recognizer. The question is, do you want us to find help training examples? I don't, because I'm going to provide the training examples myself. I'm going to call this the ScaledML 2018 detector. Hit finish, and now I land in studio mode, where I have to provide examples of Reza. Let's add a celebrity here too. I'm going to add Daniel Craig, largely because I'm a little short on time, and I usually ask the audience to do this. You can go in and do this yourself after the talk. Create a detector for any celebrity you want. Shouldn't be a problem. So we have examples of Daniel Craig. That's not a problem. I want to add some examples of myself. Very quickly, I can go in, select the webcam here, take some pictures of myself up, down, left, and right, and save that. So these are getting uploaded. Usually we only need 1 or 2 examples. Because of, yeah, so we can select all kinds of things. Going to go make sure that the Daniel Craig examples are correct. So when he shows up with multiple people, we want to make sure that we have a bounding box around the correct area, like here. We don't want to confuse him with the other guy. And we can upload frames from a video here. So if I go in, select a video, I can, this is our own video player. When we pause at any point, we can flick through frames and say, hey, I want this frame, this frame, and this frame to get uploaded. They get added into the examples at the very end. So now we would have more examples of Daniel Craig, right? I'm not going to use these examples because that's not Daniel Craig, that's Steve Jobs. But I'm going to deliberately keep one of these photos in here because that will help me show you debugging a detector, okay? So now I have this rogue Steve Jobs example, bunch of Reza examples. I can also record from streams. So if I have like this is the Matroid office. This actually should be live Matroid office. No one's there because it's Saturday and we're all here. From the Matroid office, I can record and then look at recordings and select frames to add to the detector. That's a no-brainer, right? This way, the detector will get fine-tuned to the stream that it's running on. And now I'm ready to train the detector, so I'll just hit train. And this should only take a minute or 2. What's the time right now? It is 10:29. We're doing OK for time. So this should take a minute. While that's happening, I'm going to go find maybe a YouTube video of Daniel Craig to run. So I have this video of him. I can run this. It's kind of a funny title. I can run this as soon as the detector is ready, which should be any minute now. So this is transfer learning. There's a point where we stop telling details, and this is, we decide how much detail are we going to go into. This is where we're going to sort of not go into what's happening behind the scenes here. There's a tremendous amount of transfer learning. It is not the simple transfer learning that you might think of, which is take any network, chop off the last layer, use that representation, and build on top of it. There's some architecture search going on, and much more that we will announce when we're a little bit more established and can weather more storms, but it's sort of too important to our business right now to give that away. Now the detector is ready. I'm going to be able to use it. I can, of course, run it on myself. I can sort of start putting my hand over my face to some extent so that we can handle difficulties in obscurations, right? The more I cover my face, the less sure it is that it's me. Eventually, it should say that it's not me at all, right? And of course, we should be able to run on Daniel Craig's video. I just dump in the YouTube video. What happens is we go to YouTube, we start streaming from YouTube. At the same time that we're streaming, we start annotating the video with who we think is showing up in there. So we say, I want to look for Daniel Craig. I want to say, get notifications for when he shows up, when the smallest indication that he shows up, with the smallest indication that he shows up. And you see now the timeline has been annotated with where he shows up. So I think we should get him even in there. We missed it for a second there, but there he is. He's there for a second, goes away, and then he should come back there. And then he's sort of there in the frame for a long period of time talking to this person, right? I won't unmute it because it sounds like it's a funny video. So he's there for some time. This is something like 5 frames a second with interpolation in the video. And the fact that it's 5 frames a second is arbitrary. We could jack this up to higher level as needed. So yeah, the back of his face we don't get, and I guess we didn't get that part where there's something in front of his face, but then we got him there. So I can do everything that I showed you earlier with this detector, right? No problems with that. Before I move on, though, everything has so far been click and drag. Everything has so far been click and drag and point and click, drag and drop. Now I want to show you the parts of the flow that require a little bit more insight and a little bit more engineering chops. Of course, everything is available via an API, but that's not what I mean when I say engineering chops. When you have an API like this, almost anyone who's had basic college-level programming can use the API. That's not what I'm saying here. I want to go in and inspect the performance of the model. I can do that by looking at Matroid board, which is our interface into the model through TensorFlow. This is built off of TensorBoard, and here we can see, okay, things like what are the accuracy of this detector on Daniel Craig and on me. What are the mistakes that the detector makes on its own training examples? These are the mistakes that it makes, and that's quite interesting because it's one of those Steve Jobs examples that we selected is a mistake that was made. And then furthermore, this one is also a mistake for Daniel Craig. I guess this doesn't even, I wouldn't be able to tell that that's him. It just looks like a guy in a hat and glasses to me. We can inspect the neural network if the neural network is one that you have access to. You can look at distributions of the neural network, histograms of the trained neural network, and then a projection of what the detector sees. So this is actually a pretty useful projection in that what's happening here is the colors, if you see, these are vaguely blue colored and these are vaguely red colored. The red colors are what are correctly labeled as Reza in the studio, and then these ones are labeled as Daniel Craig in the studio. And then the position in space is basically what the detector thinks it's seeing. So if we see a clustering of the blue and the red, then we know the detector's learned something reasonable. This is a PCA embedding of the learned model. And so you see that the Rezas are clustered together, the Daniel Craigs are clustered together, and I'm looking for actually the Steve Jobs example. It should be somewhere here separated from the others, and that's it right there. If you see that, that is, this one example of Steve Jobs is sort of separated from everything else. It is correct, it is supposedly correctly labeled as Daniel Craig, but of course it's not correct. And so this sticks out. So when you're going in to give feedback to the model, you would look here for the kinds of things that you need to fix. And then how do you fix it? Well, you give feedback everywhere that you see a detection. So everywhere that I saw a detection, I can give feedback. In the calendar, for example, I can give feedback. In any of these, say I have that car example. Now I can look at this. There's a person there and there's a car there. I can say yes or no, that is indeed correct or incorrect. And if I go and run that detector that we made, I can give it feedback on the fly right there. So I can say, well, let me add, I'm going to put my hand up as an example. So that's obviously me, right? And it's correct, it is me. Now if I hit redo detector, what happens is I'll land back in studio mode with the feedback available. So I can go in and that's the feedback that I gave, now that's added. And I can go in and of course I would want to remove that bad example. And now I would retrain and I'd have a better detector because of the observations that I made. And then this should be a better detector. I then would use that to monitor a stream or whatever I want. So this has all been fairly useful for someone who wants to have a sort of a Photoshop for computer vision. What if you have your own model? As a new feature, we have now the ability to import your own model from any TensorFlow model. So if I have a gender detector protocol buffer from TensorFlow, we actually provide, as of today, free hosting for TensorFlow models. So you can go in and, so by the way, this is saying, oh, well, we already have a gender detector. Would you like to use it? I'm like, no, I want to continue building my detector. I'm going to upload a TensorFlow model. I get asked for the protocol buffer. I have to give it the protocol buffer. I have one here, ready to go. It gets uploaded, and then it will be ready to use as a regular detector. These are TensorFlow models that are of the form image in and a tensor of scores out. Any of those can be simply added in as a model, and then that will get all of the benefits of the cluster, like scaling and the calendar and all of the things around it will be there. And so now this is my TensorFlow model imported. I can then run it on myself, and hopefully it says that I'm male. We'll see. And that works, right? So this is one of many ways to add detectors, and we'll be adding more and more. We essentially, when I said detectors are first-class citizens, we expect that this will proliferate as time goes on. As more and more things can be detected in the world with computer vision, there'll be models available for them, and we want Matroid to be an easy place to use them for free, right? So this is just the beginning, right? So now I want to show you some of the more interesting features that are going to go even deeper into combining detectors together. So much of what I've shown you has been surrounding sort of people and personalities. Let's focus on making a detector for something different, like an airplane. Here I have that detector that I showed you earlier can actually handle it can handle things like let's see. It can handle things like airplanes. So if I upload some examples of airliners to it, it will put bounding boxes around them and say these are airplanes. That's no big deal. What if I wanted to create a detector then from this detector to say whether it's an airliner or a fighter aircraft? So I should be able to do that with Matroid. How would I do that? This is the first thing that I want to show you is we can now specialize detectors as you want. How do I do it? Well, I'm going to create a new detector that is exactly going to be the same flow as before, but then I'm going to combine it with this detector that I just showed you to get bounding boxes. So I'm going to create a new detector. What am I interested in? I'm interested in airliners and fighter aircraft. And I hit create detector. I'm going to land in, well, first of all, I'm going to be told there's one that is already there. Would you like to use it? But I don't want to use it. I'm going to use Matroid stock images in this case. And we call this the ScaledML 2 detector. What happens now, I'll land in studio mode with examples of airliners and fighter aircraft. What do I do with these airliners and fighter aircraft? I would like to create a detector. I can just hit train detector. And when I do that, I'm not going to train it again in front of you because that's not a good use of the time. When I hit train, what will happen is I'll get a plane detector. And it will look like this. It'll be a plane type detector. It will be a classifier. It will only be able to say whether the whole image, it will only be able to say whether the whole image is an airliner or a fighter aircraft. So in this case, it would say these are airliners. Yeah, that's fine. But what if it's a mix? What if there are both airliners and fighter aircraft? Then it gets confused. It sort of says it's sort of 15% one or the other. What we need to do is we need to add localization to this model that we just created. So we can create this airliner or fighter aircraft model, but we need to add localization. How do we do that? Well, there's this little advanced button that says add localization. Where are you going to get the localization from? Well, these are all planes, and we had a plane localizer. So we need to combine these two detectors together to focus on the planes. So I'm going to say, yeah, I want to focus on, I want to take the everyday objects detector that I had, take the airplane out of that. Whenever the everyday object says there's a plane with 15% confidence, that's one of the things I want to run through this new detector that I have. And then I can put in all of these examples, and hopefully what will happen is this composite detector will correctly classify the airliners versus the fighter aircraft versus the fighter aircraft, fighter aircraft, fighter aircraft, airliner, 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 airliner. So now I can use this detector to both localize and classify fighter aircraft versus airliners, as opposed to what I had, the ability that I had before, which was to just do airplanes. So now I have this new detector, I can go in. And then let's say I wanted to look for pink aircraft versus blue aircraft. I could go in and compose this one more layer and add in another detector, and just it can be detectors all the way down, right? So this is the first feature that we're announcing today, which is composite detectors. We're getting a lot of mileage out of this. We're seeing a lot of usage from our customers, and so we're quite excited about that. This is one way to do detections here. I'm going to move on to the next one for the sake of time. I gotta run fast here, which is sliding detectors. So one more thing I want to show you. Let's go back to everyday objects. And let's run some imagery from the air now. So I have some aerial imagery here of an airport. I run this through, and what will happen is sort of a spectacular failure because this detector isn't that good at multiple planes all from above. It kind of sucks at that. And now I need to improve this. What I'd like to do is to have the detector focus on every little patch of this image and classify separately. And so, of course, that is the feature that we're announcing now, which is the ability to slide a detector across an image. And again, I'm just going to go into the Advanced tab, hit Create Sliding Detector, and there's a little animation here that tells you what's going on because it's actually quite weird to just have the name sliding detector and not explain what it is. So we have a window width and a window height and a stride, much like a convolutional patch goes across an image, or we can run a detector across an image. So I'm going to name this sliding aeroplanes. This is NMS, so what is the threshold at which two bounding boxes overlap that you only take one bounding box? And then I'm looking for aeroplanes. I'm interested in getting bounding boxes for airplanes, even very low probability airplanes, low confidence airplanes. And then I have to give the parameters for the box. So here I'm just going to try 300 by 300 window size and a 300 by 300 stride. This is the stride, as you see, horizontal stride, vertical stride, and the window size is given there. So I hit Create Sliding Detector. This is fairly immediate to create, and it will be a new detector that then I can run this airport over, and then I should now get a much better classification of what's going on. It's going to be slower, of course, because there are way more classifications going on, but we don't care because we have a whole cluster backing this, and we will optimize that, but first and foremost, I want to get a detector working. And so now I have the airplanes all classified, and I could then take my fighter aircraft versus airliner detector and further specialize this detector with it so that it's chains all the way, combining detectors in left and right to your benefit. There's one last place you can combine detectors together. I apologize, we have so many things to show you, and I wonder if we overdo it, but we're too excited to not. So one more place where we can merge detectors together. So if you recall, I was working on that pending detector with the airliner and the fighter aircraft. And this studio lets you annotate as you need. And we really try to make the studio as fast and as easy to annotate as possible. So of course you can annotate yourself, but that's boring, right? Why would you want to annotate airliners and aircraft yourself and put these bounding boxes in? That's hella boring. So in order to get around that, we already have a detector that does planes. Why not use it? Well, we can. So we can go in and say, I want help from a detector. I want help from a detector to look for airplanes here, and indeed I can do that. What's going to happen now is I'll just get automatic bounding boxes around the airplanes in this page. I can cancel it and they'll still show up. So now I have automatic bounding boxes around the airplanes. I've now saved myself a ton of bounding box drawing time, and I can create this detector even faster than before. This is yet another way to combine detectors, and you'll see more of these as we build them. We think the computer vision to really go and detect everything. This is our mission: is to detect everything through computer vision as much as possible. I think it's a never-ending mission because computers are essentially getting eyes just now, and much like humans understand things, it will essentially need AI to be solved to be able to detect everything. So I think our company mission is never ending here. But we'll chop off as many pieces as we can as we go, and this is many pieces chopped off right now. So you've seen several ways to put detectors together. The last thing I want to show you is connecting a stream to Matroid. So I have here many streams. I can connect many streams to Matroid. One of the new features that we're announcing today as well is the ability to put in arbitrary streams through rtmp. So there's a rich ecosystem of tools from places like Twitch, Ustream, YouTube Live, and Facebook Live that allow you to stream live into their services so that you can do whatever you want with your video stream there. Today we're announcing all of those services are essentially supported with us so that you can stream live using all of the tools that you used with those folks. Those are all using rtmp ingestion, which is a protocol for video streaming. And so here I'm going to create an rtmp stream, call it some stream. And when I create it, I get given an rtmp URL to stream into, and this is why Nginx has the rtmp available, and a stream key. I can then take this stream key and put it into whatever app I have. I have an iPhone app. There are many Linux, Mac, Windows, everything. Every platform has an rtmp streamer because all of those streaming services demand it. And so there's just a proliferation of these things. And you can take these streams and bring them in from wherever. And by the way, everything I've shown you is free for use for like 10,000 API calls. So I hope this actually helps in research because you'll be able to create detectors as you need. And if you're an advanced enough researcher that you can just take the TensorFlow model and use it, all the more power to you. This is very much open for you. So let's say I want to. I have this on my iPhone. The last thing demo that I want to show you is it running on my iPhone. So I have to open this app called Broadcast Me, and then it should start broadcasting me. And I'm going to monitor myself live from my phone. Hopefully this works. There's all kinds of weird things with the internet. But let's say I'm going to run the detector on my iPhone and say looking for, just going to look for people, right? There we go, right? So this is streaming directly into Matroid servers. We're detecting a person, and indeed the person's being detected. And so there are a lot of platforms that you can hook this up to. It's essentially unbounded where you can get video streams from now.